Number 26 says rewrite the equation using function notation. What that means, guys, is we've got to solve this for y, and then we just replace stuff, okay? Wherever we have a y, we replace it with an f of x. And that's tricky because one of the first things they give you is a, which is got an f of x in as a replacement, but it's not solved yet. Function notation means we've got to have f of x by itself. So I go ahead and solve first. So I've got negative 2y. I subtract x from both sides. I get negative 2y equals negative x plus 8. Divide by negative 2 and divide by negative 2. That negative 2 goes to both pieces. This would be a negative 1 in front of here. So negative 1 and negative 2 becomes a positive 1/2 x minus 4. The last piece is the fact that we're actually putting this in function notation. So it becomes f of x equals 1/2 x minus 4. Answer should have been D. 27, solve the system of equations. So this time they just straight up tell you, hey, solve it however you want. Okay, they didn't tell you one way or the other. You can solve it however you would like. Now, a small tidbit of a test-taking skill. If you forget how to solve systems of equations, this is an x value and this is a y value. You can take this x and this y and plug it into this first equation and see if it's true. Then plug it into the second equation, see if it's true. If they're both true, it's a solution and it's your answer. Okay? But I'm going to do this the more traditional way. I look at these and I say, okay, they're already lined up, so I'm thinking elimination method. And I look at the y's. I can multiply this bottom equation by negative 2, and all of a sudden I have 4x minus 2y equals negative 16. Well, when I add my top and bottom equations together, I get 7x. These eliminate, and I get negative 14. Divide by 7, x equals negative 2. That's half my answer. Okay, but if I look at my choices, I can see that there's only one answer left. It's the only one with a negative 2 in front. Just to be safe, you would be more than welcome to take this and plug it into an original equation. If I did that, I would plug it into this top one. That'd be negative 2 times negative 2 plus y equals 8, resulting in 4 plus y equals 8, resulting in y equaling 4. That is, in fact, my A answer. That's where they would intersect. Okay? 28. He owns this deli. He wants to know, is there anything he can tell from temperature compared to how much he makes in sales? Well, there is a little bit of tendency for this to seem like it increases, but look, its lowest point is way up here at like 92.5 degrees. His highest point's randomly at 80 degrees. It does not look like there's really any solid coordination between this data, okay? You could argue, man, maybe it's got a slight temperature increase and sales increase, but for the most part, there really doesn't seem to be any sort of relationship. That's really thrown apart because if you try to draw a line through here, it hits a lot of points, but look how much it misses some of these points by, okay? So I would say this data has no relationship. You could make an argument for this data increasing as our temperature increasing as more lemonades are sold. So if you made the argument for that, that's okay, but really there's not much to do with this. Plus, there's such a small increase, it's really not that big. Okay, it's pretty flat, pretty spread out. Number 29, solve for x. Guys, don't need to be missing this one, okay? We've done a bunch of these throughout the year. Now, I notice that's an inequality symbol in the middle, not an equal sign, so I've got to watch out for that. First things first, probably should write the equation down correctly. But first things first, I have to get all my x's on one side together. So I'm going to add 5x. Why I choose to do that is because now I know my x's are going to be positive over here. It just saves me a step, okay? What I have is 2x minus 6 is less than negative 2, because those canceled. Next, I've got to add 6 to both sides. I get that 2x is less than 4. Divide by 2, divide by 2. X is less than 2. A should have been our answer. Number 30, consider the characteristics of the graph. Which statement does not describe the data set? The interquartile range is 10. Well, this is my Q1 and this is my Q3. So my IQR, and this is on your formula sheet, is Q3 minus Q1, which is 40 minus 20, which means my IQR is 20. So it looks like this one does not describe my data. Just to be careful, check the other one skewed right. This looks skewed right to me, so that is true. Median is 30. Median is 30. Range is 60. That'd be my maximum minus my minimum. Okay. The only one that wasn't true that did not describe our data was A. 31 is a time-consuming problem, and that's what it's here for, guys. There's two ways to do it. One, you can type each of these sets of data in your calculator. You can stat plot them. Do a stat plot of a histogram with the right frequencies to make sure it matches. Even then, it's hard to tell the heights of the different bars. Personally, the best way I would go about this one is just check them all one by one. What that means is for this range of 50 to 54, we should have 2 points in our data set. So we're looking just for numbers between 50 and 54. Let's check A. Oop, there's a number between 50 and 54. There's another one, so it checked out. As I check B, I see there and there. So these data sets are almost written in the same order with small changes, okay? As I scan my data sets, I see that all of them passed this first test. Moving on to our second one, between 55 and 59, we should have a frequency of 3. So 55 and 59, there's 1, 2, 3, 4. Uh-oh, that one had too many in that range, so it's out. 55 through 59, 1, 2, 3. That one's clear. 55 through 59, 1, 2. Uh-oh, that one was missing one as well. C's out. 55 through 59, 1, 2, 3. So we've gotten rid of 2 of our 4. Okay, if you're running out of time now, you could still guess. You'd have a 50% chance. 60 through 64, this range, we need only 1 piece. Oh, I don't know why I'm even looking at A. We've already X'd it out. 60 to 64, there's 1. There's 1. They both only had 1, so they're both good on that one. Ooh, 65 through 69, we need 4 pieces. So this will take some counting, okay? We've got 1, 2, 3, 4. Why am I doing A again? Sorry, guys. Sorry. I don't know why I'm bothering with A. I've already gotten rid of it. So let's take some time and just draw a big line through all of it. That way we don't make that mistake again. We're done with A. We're done with C. We don't need them. What we're doing is we're checking 65 through 69, this range for that frequency of 4. Okay, so 65 through 69. That one had 4 of them. That's what it should have had. 65 through 69. 1, 2, 3. Uh-oh, this one only had 3 of them. Okay, so it's finally out of the running. Again, you saw me. I made mistakes on that one. I looked back at data sets. It's just a time-wasting problem, okay? Time-wasting problem. But your answer should have been B. Number 32, charges a flat rate of $20 and then a fee of $5.75 for a bucket of balls or per bucket of balls. Write an equation that models the charges C, so this is our charges or our total, in terms of the number of buckets of balls B that you use. So the flat rate is the part that you just tacked on the end. The $5.75, you've seen a bunch of this in Carnegie. The $5.75 is what gets your variable. So I'm looking for something that charges $5.75 per bucket. This one does. This one's good. This one's charging you $20 a bucket. $5.75C, $5.75 cost? No, that doesn't work. And that doesn't work. Just to be careful, make sure your flat rate of 20 is also all by itself. And that should be our answer A. That's our correct equation.